Hello, it's Sean and welcome back to Having Fun Repairs. I've got a little toy dog here. I don't necessarily know what it is called, although there's a tag that says Playtech on it, made in China. This is a gift to one of my kids on their birthday, given to them by a friend, and it doesn't seem to operate. I'll put fresh batteries in here. I'll take them out. It's on and off switch. A little button. It doesn't seem to be doing anything. But just to show you that the batteries are fresh. It's two AAA 1.5 volt batteries. Should be able to make a DC measurement. We'll have around 3 volts or greater. Let's go from here to there. We have 3.2 volts, and then individually 1.6 and just under 1.6. Oh, you can see that again. Untwist my leads. Oh, 1.6. Alright. Another thing we could do is just make sure that the voltage is coming around all the way, which we did measure in DC voltage. We got some value, but you can see there's no loss in continuity between this pulse, these two posts here, so that means that we shouldn't have continuity here. You're in about 31 mega ohms, quite a substantial bit of resistance. So in my head, whenever I look at a kid's toys, you know, I think common things like maybe the switch is bad, there's probably a wire inside that's broken, or maybe the motor on this is seized up. I believe this is motor driven. But I will say, like, even though, and I can even see a speaker, and it wasn't making any sound when I press this button. I'm not sure if this button actually, when you turn it on, if it does anything. It has to be pressed to get this little toy dog to start making noise and stuff. But you know, somebody who repairs a lot of kids' toys, consumer electronics type deals, I have a tendency to get ahead of myself and think, well, this is probably the most likely issue. And while it's good to have experience in everything, sometimes you should wait till you observe and follow simple troubleshooting methods before actually coming to a conclusion, because you can head yourself down the wrong path. And by simple troubleshooting methods, what you can observe, what you can test, and then what you can theorize based off of observation and testing. It appears like zip tie is holding the body onto this base, so we'll cut that and we'll get this thing open. Just like I stated, looks can be deceiving. What we have is a little single board integrated circuit. What I thought was a button is actually an IR receiver. So you would have a signal coming in. And I can also tell by the way this board's populated with this resistor and capacitor there, this is acting as your IR receive antenna. So what you would have is a handheld device that's going to produce a signal, or probably one or two, I'm going to assume at least two, that will hit this IC right here. It's a little 8-pin surface mounted IC. There are absolutely no markings on top of it, but I presume this is a IR decoder, meaning depending on how that signal is, what is being transmitted over that signal or modulated over that infrared signal will determine the output of this to this IC right here. As it appears, our leads come off and down and over to the two center pins. So I imagine the two center pins are going to be the input, and it looks like this outer pin is going to have our positive DC voltage on here. Let's take a couple voltage measurements, see what's actually going on. And so I currently do have the device still on. That wheel's going to fall out. I'm just go ahead and take it all the way out. It is on. Batteries are in. So at this point, I should be seeing that 3 volts. See if we do, and yes, we do. And is this going to go to here? It doesn't go to there. Where is this going to? There has to be a 3-volt source on here, and there is. So 3 volts is fed to here and here. One of these is probably dealing with a clock, and another a reset. Should be having receive and transmit, or an output of this IC heading to these two center pins, and we don't. We do have 3.2 volts there, and I'm willing to bet we'll have 3 over here as well, won't we? Yes, we will. Because on the back end, it's like we have this pin heading to this wire, this white wire leading down to our motor here, and this one is coming off of this outer pin down to the motor. So, and there's no speaker. So I believe more than likely, and you can see that there is a surface mount device not populated on here. This is probably a similar device used in other toys made by Playtech, but some with some additional features such as sound. Something that's going to produce a sound or a piezoelectric speaker. Now this feeds to the motor, and we don't have anything of that output currently, do we? Nope. Nope. Nope on that outer pin, and nope on this outer pin. Willing to bet if I was to put a short between our 3.2 volts to this pin to the center pin, or that outer one to the center pin, that's going to drive these wheels. A quick note, as it goes forward both wheels spin, but as it goes backwards only one will spin. So this is one of those cheap toys that has a single forward and reverse function, no left and right turn. And the wheels are not made, including the front one, they're all stationary wheels. They're not made to pivot at any point. So what would occur is this dog would move forward, when the remote is pressed to go forward, and then in reverse, one wheel will stop while the other one continues to roll, causing it to change direction simply by one wheel being able to turn. I want to short out these two pins here. And that appears to be the reverse. And it is. And let me short out these two pins here. And that is definitely the forward. Come on. Yes, that is. That's pulling it forward. Okay. So now I just need to make a determination as to the polarity of these wires heading to here. And I can do that by simply connecting to the battery. So let's put positive on green and ground on the white wire. And then we'll go from the negative positive terminal on here. Yep. So green will be positive and white will be negative. So the best I can do to get a working toy is to really just simplify this. No reverse, but we can do forward. And I think that would make my kid happy. So what I will do is I will desolder these two leads from this circuit board and solder them onto these two leads over here and completely remove the circuit board. And maybe I'll have a use for this in the future. There is looks like it appears to be a model number on here. Let me look that up online real quick. Ain't nothing really worthwhile to find online. Somehow cross references to a Citroen C2 part. Pictures don't really produce anything worthwhile. Potentially Bluetooth chipset. That's what I'm seeing, at least on this first link here, but obviously that's got nothing to do with the part we have on hand. So really not worth my time. Okay, so that is exactly what we're going to do. We're going to desolder those wires and put positive to positive and negative to negative, so when it turns on it'll at least go forward. Until which I can find a better use for this little PCB here. We've got your doggy modified and put back together and zip tied. Are you ready to test them out?
Yeah.
Yeah, what was his name again?
Puff.
Puff?
Like Puff Marshmallow.
All right, turn him on. Let's see how fast he goes. Uh-oh. Oh, Puffy's going. He's quick, huh?
Yeah, when you said.
Wow. Are you happy with that, bud?
Yeah. Yeah. Yeah.
Yeah? High five.
Daddy, he's happy.
He is. Well, we restored some functionality, although not optimally, because we don't have an IR transmitter. Did a little bit of reverse engineering on this little circuit board here, PCB. There goes a close-up of the actual part number. If anybody can find anything, then tell me in the comments down below. JG-8149R-1. Anyways, I wanted to go over this circuit diagram real quick. You have your 3-volt source, positive, negative. You have your first IC here, your second IC there. This is called the IR detector, and then the motor driver IC. No clue what it actually is. Again, no part numbers on it, so I can't really find anything directly about this. However, you have your positive rail feeding to pin 1 of the IR decoder. It's also feeding to either pin 1 or pin 3 of your IR LED receive diode. Ground is on the center. I just put a ground there instead of tying it all the way to the bottom. Same thing coming off of this motor up here. You see this little ground center. I just didn't feel like running the lines. So let's go over what's occurring. You have an IR transmitter that's going to produce light that the receiver can pick up on. It will be a pulse width modulated signal at a frequency, my guess is somewhere between, I don't know, 20 to maybe 50 kilohertz, I think, for this type of device. I mean, other devices could be higher, could be lower. Anyways, your little LED receiver here, our receiver here, has to be powered. It is by a 3-volt source. Center pin is ground, and then that third pin is going to be the output. So as that pulse width modulated signal is coming in, being transmitted over light, again IR, infrared light, it will be detected by the receiver and outputted to the IO decoder, IR decoder, which in turn will produce an output to this motor driver. I think it's going to trigger either, this is pin 1, 2, 3, 4, pin 5, or pin 6 to produce an output. Now, what I believe is occurring here is that something is going to trigger the same 3 volts to output over pin 4, or excuse me, pin 5 or pin 6, which is fed into the motor driver. And this is what's going to control the motor. And here's what I think is occurring in the motor. Again, this is just super simplified, might not even be correct. Somebody can redo this, put in a doobly-doo, send me a diagram of what you think's going on. I think what you have is a comparative circuit, 2 AND gates, meaning they need at the input something and something else to get an output. So what this means is pin 1 and pin 4 already have that 3 volts DC tied to it. That's going to be a constant. And these inputs come from this IC here, depending on what logic is switched going in. So what I think what occurs is you have a high here and a high here, and then no signal here, so thus you'll have a low on each output, right? I think that low is tied to ground coming from pin 6 and pin 7 somehow. There's probably something in between. I don't know. Again, somebody smarter than me put some comments in the doobly-doo. So, as this decoder, IR decoder, receives the signal for forward, it's going to output 3 volts over one of these 2 pins. And as 3 volts comes in, let's just say that it's this U1, 3 volts comes into here. Now you have a high here and a high out. So now you've got 3 volts coming into the motor, and the other comparator is supplying the ground. And then you let go of the button, it stops, returns back to nominal, low and low. So let's say that's forward movement. Now we do reverse. Well, in reverse, this will stay low, so this is going to stay low here. But in reverse, the voltage comes in to here. Now again, I don't have the remote, so I can't really remember, because it's been a few days since I worked on this, which pin outputted forward and reverse. So, you know, if I'm wrong in how I present this, whatever. But let's say reverse comes into pin 2 on here, the second comparator. Well, now you have a high here, that signal to trigger reverse. So you have a high, so this switches to a high here. Now the motor is driven in the opposite direction, with positive to here and negative to there. Seems like it'd be pretty simple enough. But like I said, I don't know what frequency and how this is modulated in order for this IR detector to produce the correct output to drive this motor IC here. And that's simply because, one, you need to know what the frequency is. So, and now this pulse width modulated, so it's going to be a square waveform. Okay, sorry. Ignore this line right here. So between this and this, your highs and lows, you can determine, and the spacing, you can determine what the frequency is. Okay? And because you're talking about a full revolution, whatever word I'm looking for, in time, that will tell you what frequency. However, you need to know how long to produce a high versus how long to produce a low. 0, 3 volts, I'm going to assume, based upon the circuit. So this will be my high. This could be the low. It could go back high and back low, then back high, then back low. I know these aren't directly the same width, but let's say that that's 2 microseconds high and maybe 0.5 microseconds low right through here. Well, that could represent forward, but again, I don't know, and there's no way for me to determine that without A, having some data concerning this IC, or by trial and error if I had an IR transmitter, programmable one. I mean, it could be something like that. It could also be something like this, where it's high for a short amount of time and then low for much longer. And that could represent forward. But to demonstrate to you a little bit of what I'm talking about, we're going to perform a little experiment using a TV remote. So what I'll do is say the bottom was positive. Okay, I'll hook a power supply up to provide 3 volts to the positive terminal on here, and we'll make this bottom part, the middle part was the negative terminal or ground. Let's see if I can get this clipped on. And then we're going to hook the top part, which is our output, to an oscilloscope. An oscilloscope probe. I'm going to lay this on the board. Just double inspect that nothing is shorting here, and then I'm going to use a TV remote as an IR transmitter to hit that diode right there, that receive diode. Let me turn my power supply. Up to 3 volts. Coupled to DC. So my ground reference line is center. Now I'm going to turn this up to 3 volts. You'll see that line increase. There. 1. So I have it on the 2 volt scale. So from center to there was 2, and then it's halfway up, so that represents 3. Okay. Then I'm just gonna point the remote at this LED and press the power button, and you should be able to see, hey look, there goes that pulse code modulated chain right there. And this remote is transmitting at, let's give it some time, maybe 300, 480, 500 hertz. It's definitely at least in the hertz range. Oh, it hurts. Let's try to expand this out a bit. Oh, you can see that pulse train coming through. You can see that you have some that are on longer and down lower. Let me try the 1. There goes a pulse train for 1. Come back this way a bit. 1. Power. Pressing the 2 button now. 2. 9. As you can see, as I 320.5, 370. 1 is 330, or that was 4, 333, 364.9. I demonstrate that and tell you which buttons I'm pressing, etc., to simply show that as each button's going to represent to a different carrier frequency, and then the times where that frequency is high versus low is also important concerning the functionality of, an IR transmitter to whatever it should to the receiver in order to decode to tell the device what it should be doing. But anyways, again, not something I could do without the appropriate equipment. Maybe if I had an arbitrary waveform generator feeding into a IR LED to transmit, or signal generator or something, I could perform that function, and then just guess at the frequency, and then guess at how it's pulse width modulated, and trial and error so I get something figured out. But again, that's going to take a lot of time, and I just don't feel like doing that. But anyways, if you found this video informative and enjoyed it, please give it the good old like button. Consider subscribing, sharing, And yeah, thank you for watching. Take care. Bye.